Hi and Assalamualaikum to Dr. Saiful Iskandar. I am Nur Adila. We present about flood hazard modeling and flood forecasting. For introduction, flood hazard modeling to determine the source of potential flooding, the extent of flooding, and the proposed mitigation and protection measures. Flood hazard forecasting is developed an essential tool in decreasing vulnerabilities and flood risks and form an important step of the strategy to handle with flood, thereby leads to national sustainable development. The first methodology of flood hazard mapping and modeling using GIS that presented in this study include hydrological frequency analysis, hydraulic modeling, hydrological modeling, and statistical methods. Hydrologic frequency analysis use historical flood data to calculate the probability and extent of future flood events. Hydraulic models convert discharge flow values into stream or flood depth. The Hydrologic Engineering Center's river analysis system model calculate and estimate the duration and extent of inundation, changes in water depth, and velocity through time at any location. Hydrologic models use mathematical calculation with known or assumed values for various components of the hydrologic cycle to analyze the behavior of stream flow and flood in a specific watershed. Statistical methods combine historical flood frequency and distribution of flood causal factors in order to predict areas with a probability of flood across a geographic area. This method allows for the calculation of a flood hazard index, FHI. The implementation of methods and process described just now requires the following software, which are ArcGIS 10.0 Spatial Analysis Extension ESRI, which is one of the application of a flood hazard model, MATLAB 6.0 or higher, the ITLAS Clean Mode 1.0 application, and S+ 6.0. The Malaysian Flood Hazard Management Program has always been based on a structural approach, such as the construction of flood control structures, and through the application of new technologies, such as the use of remote sensing in flood forecasting and telemetry and automatic warning gadgets in flood warning and evacuation systems. The MFHMP is largely based on, first, structural measures of flood mitigation to modify flood hazard before they occur, and then flood hazard response machinery when floods occur. The flood hazard response machinery is essentially a mechanism of actions set up by the National Security Council to respond to seasonal monsoon floods each year. The NSC heads the machinery that can institute a real-time flood warning system based on the above-mentioned state-of-the-art forecasting system. The DID is the authority which forecasts the flood and release the message to the NSC, which then order a warning to be issued. Warning will initiate the FHRM, which police will start warning people. The army will get their trucks ready and all other related departments are put on standby. The Department of Irrigation and Drainage Malaysia (DID) come up with the flood forecasting and warning service to the public through a program called the National Flood Forecasting and Warning System. The Malaysian Government Department of Irrigation and Drainage, Jabatan Pengairan dan Saliran, provide a flood forecasting and warning service to the public. JPS is rolling out a program based upon the phased implementation of system, with together form a new national flood forecasting and warning system for its key river basin. The objective of the new NAFFWS is to develop and maintain an effective and efficient integrated flood forecasting and river monitoring system with flood warning dissemination using national telemetry network data, radar data, and various rainfall forecasts. NAFFWS is a tool designed to enable effective decision support by JPS. There are new tools available in HECRAS version 5.0 software, which is a free modeling tool. A 1D and 2D approach was found to be appropriate for flood mapping to map flooding extent and depth under different extreme scenarios, accurately reproducing the flow of water in both large floodplain and urban areas while reducing computational requirements. Other than that, 1D and 2D hydraulic model is used to simulate flood events, enabling us to have a better understanding of flood risk, allowing us to develop options to manage that risk. 1D models is the simplest and most common practice that used to treat flow one-dimensionally along the river channel, while 2D models can provide more detailed results and have gained in popularity. They remain computationally and data-intensive and therefore difficult to apply to large areas. Recent advances and software developments, a new version of HECRAS version 5.0 was released in 2016, allowing for full 2D modeling and linkage between 1D and 2D feeders. Couple 1D, 2D models can dynamically represent coastal, urban, river and floodplain interaction and are therefore well suited to assess the impact of flooding from different sources. The result can then be used to determine level of flood protection, developing mitigation and elevation options. And then there are another approach which involve the use of geographical information flood forecasting system that includes the generation of a series of flood maps. This is one of the economically effective non-structural approach in flood mitigation and flood management, which using a geospatial technology that involve flood forecasting and warning service to the flood-prone areas. There are three types of flood maps, namely flood hazard map, flood risk map, and flood evacuation map. Flood hazard map is used to determine areas susceptible to flooding when discharge from a stream exceed the bank full stage. Early warning of incoming flood events will enable the flood victims to prepare themselves before flooding occurs. An early warning with reference through a series of flood maps, including flood hazard map, flood risk map, and flood evacuation map of the approaching flood should be able to alert the organization in charge of the flood fighting actions. The authority undertakes the necessary decisions and the general public will be aware of the impending danger. A development flood river water level forecasting utilizing a hybrid technique called Adaptive Neuro-Fuzzy Inference System (ANFIS) model. The ANFIS model is designed to forecast river water levels at the downstream area in hourly lead times. River water level, rainfall, and river flows were considered as input variables located in upstream stations. ANFIS model shows better results in terms of coefficient correlation against artificial neural network-based models and support vector machine models. This is the list of my references. Thank you.